Today we're going to talk about exponents. We're not going to take too many notes about them, but we do want to clear up some misunderstandings that you may have. So the first thing we're going to learn are some important vocab words. So when I see the expression, this 2 with a 4 above it, we call that an exponential expression. So big word there, but we do call that an exponential expression because it has an exponent in it. The bottom number or the big number is what we call the base. And the reason it's called the base is we think of base as bottom of something. So that is your base, it's on the bottom. And 4, as we know, is the exponent or power. So sometimes we say exponent and sometimes we say power, but they mean the same thing. So when I read that, it reads as 2 to the 4th power. Sometimes you'll hear me say 2 to the 4th, or I'll say 2 to the 4th power, but they mean the same thing. So if I have 3 with a 5 above it, that's pronounced 3 to the 5th power. So make sure that we know how to pronounce them correctly. That's really important. So when I see 2 to the 4th power, that doesn't mean 2 times 4. It means we're going to multiply 2 a total of 4 times. So we just kind of think, what's 2 times 2? Well, that's 4. 4 times 2 is 8. 8 times 2 is 16. We should never, ever multiply big numbers with little numbers. We should never, ever do that. Powers are called powers for a reason. It's because they're really powerful. They can take a small number like 2 and make it into a bigger number like 16 really quickly. So we have to be careful about that. Exponents grow very quickly. We're going to work backwards a little bit and we're going to condense long expressions. The whole reason for exponents is so that we don't have to write as much stuff. That's the whole reason we use them. So if I see 3, 1, 2, 3, 4, 5, I am taking 3 and I'm writing it 5 times. So that is 3 to the 5th power. A lot of kids think that the 3 down here counts as 1 and then there's 5 more, and so there must be 6 3s, and we don't want to think like that. That's not right. We just simply tell what the number is and how many times do we see it. That's it. So if I look at 6 times 6 times 6, the number I'm using is 6, and I see it 3 times. So in the next one, our base is x, and it appears 1, 2, 3, 4, 4 times. Be careful about this one because we have some 2's and some 7's. So we're actually going to write 2 separate exponents here. So I see 2 appearing 3 times. That all is multiplied with 3 7's. So there's 3 2's and 3 7's. I don't know why that's the same. And we just put a little multiplication symbol in the middle to separate them. So let's look at 5 to the 3rd. That means 5 times 5 times 5, which is 125. Now you can type that in a calculator, just more a lot quicker. You would hit 5. You should see a little caret button. I call it a caret. And then whatever your exponent is. and then you hit equals. And it should tell you 125. So for number 6, we're going to take -2. We're going to multiply it 4 times. So 2 to the 4th power, we said earlier, was 16. So even though it's -2, if the exponent's an even number, it's going to be positive. And I want you to write that little note down. If a base has an even exponent, the answer is positive. And that's just one rule I want you to memorize. So if you see an even exponent, meaning 2, 4, 6, 8, or 0, something that ends in those numbers, that's an even exponent. So we don't really care about the negative symbol anymore. I know the answer is going to be positive. So we need to practice that. If I look at number 7, and I try to do -2 to the 5th, I'm going to get a negative number. I'm going to get a negative because since I have a negative right here, the exponent's not even, the answer is not positive. So odd exponents that start with negative numbers will give you negative answers. 2 to the 5th is going to be 32. So the answer is -32. So if we look at 4 to the 4th power, that's going to give us simply 4 times 4 times 4 times 4, which is 256. And the last one, I know right away the answer is negative because of the odd exponent. And the shortcut with tens is to keep the 1 and write the number of zeros. So it's going to be the same as the exponent. So since the exponent's 3, there's going to be 3 zeros. That's a short way of doing it. All right, so we're going to set up the bottom and we're going to go through them. When I substitute a number for a letter, I have to include parentheses around that number. So I'm going to put 4 in for y using parentheses, and -2 goes in for z. If you don't use those parentheses, you're writing a different problem, so you have to have them in there. We'll go ahead and set up the other two. And then we'll set up the last one. So again, we're putting -3 in for x using parentheses. We're putting 4 in for y and -2 in for z. And then we'll go through and we'll solve. So now we're going to just evaluate the answers or simplify. So if we do -3 to the 2nd, I know right away that's an even number. So this answer is going to be positive. Anytime that's an even number, you're going to get a positive outcome. Then I'm going to bring down my minus sign, but I'm going to do 2 times 4 times -2, because according to PEMDAS, multiplication should come first. So if I do that, I'm going to get -16. Now you should have a minus in here. That might look weird, but that is right. So we can't be afraid to do the minus thing. Whenever you subtract a negative, it's really just adding. So we're going to change that to a plus sign, and the answer we get is 25. We try 11. We do 4 to the 3rd power, which is 64. So we should handle our exponents. We want to change those into regular numbers first. There's that -3 squared with an even exponent, so that's +9. Notice I'm keeping my parentheses because there's no sign to separate these two, so I have to use those parentheses. 4 to the 2nd, which is 16, not 8. So I can either add or I can start multiplying. I should be multiplying first. So we're just going to kind of multiply all three of those, which is going to be a big number. So if we do 2 times 9, that's 18, times 16, we get 288. And if we add those two together, 288 and 64 make 352. So we kind of get a big number there. And for our last problem, so we're going to change our exponents first. We're going to do this over here. I'm going to keep the 3, but negative 3 to the third, now that's an odd exponent, so it's going to stay negative. 3 to the third is 27, so it's negative 27. We're going to keep the 4. We're going to change negative 2 squared. That's an even exponent, so it's going to be a positive 4. So we actually just have a big multiplication problem. So we're just going to multiply all three of these together. I'm going to get a big number for this. So we get 1296, but there was a negative in here, so there's going to be a negative in our answer. And that's it.